an even more radical idea from last time with the blood filtering I talked about would be to have a blood filter that's actually built into little nanoparticles that you could inject into someone's body. And I want to briefly talk about my design for such a radical blood filtering device. One would be to have a little nanoparticle that would have on the outside this membrane that I drew that has a lot of high surface area, but naturally scrunched up and attached to this nanoparticle. So it is over here, it's all attached. Now when this nanoparticle then can expand and detach it so it becomes more like a blob, have like a little blob in the middle and has these membrane not attached and spread out. When it's all folded in on the particle, the little things that grab stuff out of your blood are folded in on cells and can't grab stuff. They're stuck. When it's out like this, they're all exposed. So how do we control when it is exposed or not? Well, one way is we could use radio waves or magnets or light waves to detach it by either heating it up or putting energy to detach it, or by doing some other chains or shaking and vibrating it. This has all kind of been done before to some extent. The other way we could do it is and they each have advantage. Radio waves and stuff can go really deep in your body, but you can't fine tune them as to specific locations much. Light waves, there might be more outside noise with like the sunlight and stuff, but you could really fine tune them just to be in a certain location. But on the other hand, release it just at the toe or something like that with a little light wave, and you could have clothes covering up most of your body so it doesn't release everywhere. But light waves can't penetrate as far deep in your body. They also absorbed more by your skin, and some might disrupt the circadian rhythm somewhat or not. They also have more energy light waves, so they can give off stuff faster compared to radio waves. Magnets are very controllable and they're very cheap, but what if you have a problem with like having metal implants or something, or interference with electronics in your body? So they all have their pros and cons. Another way is that you could use a chemical messenger to control this whole thing. But chemicals, while they can get rid of all the problems with the power source and stuff, you still have to give the chemical, and that's a whole separate step. They might be better in some cases where you don't want to have any hacking or outside interference, so you want a more controlled thing that way. The fifth one, which is kind of chemical, is internal conditions. So you could have this expanded only when your blood pressure is too low or osmotic pressure is too low, which could be a sign that you're losing too much fluids or something. You could have it also expand to certain internal chemical signals, so it does the computation for you. And one way you could unfold it is you could have stuff that can either bind to the inside particle or to the outside chemical signal and goes back and forth, or things that when they bind to outside chemical signal, they move out, and then contract the whole thing, as these things used to be latched onto here, and now they're latched onto here, or some other way modifying it. So yes, the other thing then to do to control it is you could have a sense to make sense it with light waves or magnetic thing, is you could have it when it attaches to antigen or whatever that senses a chemical. At the other end, you could have a nanoparticle or something, which has already been done before, and it spins in the magnetic field or under light or something differently if it has attached or not, because the thing is just heavier, it has more mass to spin, and the center of gravity is different. That's particularly true for magnets or radio waves. Or light waves, it might act as a sink, metal nanoparticle special, where the energy from absorbing the light waves instead goes into this nanoparticle, which either can let it emit more light or changes what the light frequency it emits. this has actually been well done, and you can change light waves, what light nanoparticle emits, simply by changing its mass and size. Now, you could even have this whole thing recharge, again, by either having it break down under a tense radiomagnetic field and then just peeing it out. You could have it recharged by injecting new ones after it's used up. You could have it recharged by using the metal nanoparticle to generate an electric field that lets go of everything under certain things and lets it go near your urinary tract or where it's filtered out. Or you could use this to transport chemicals from one part of the body to another part of the body. So let's say you want to transport more of this protein from the liver directly to the brain because that's where it's more useful. Something like that. There's a lot of potential for this, and the reason why this will be better than an outsourced thing is, first of all, mobility. The person can walk around more and everything, which is much more healthy. You could, another reason why it would be a lot better is that there's less disruption. You don't have to pump in and out the blood, and there's less chance for temperature change to affect the blood, the change in beating and stuff, which can cause blood clotting or protein misfolding. There's less chance for infection this way. There is one time you have to inject it. You have less setup outside and stuff like that. But also, you could even use the system with an outside thing, and it'll still be better where the particles still go into a blood dialysis machine. And the reason why it would still be better, and this is better overall, is that because it sucks up chemicals throughout your whole body, it gets rid of them faster, more locally, where they cause less damage, but also it doesn't cause as much change in the chemical balances anywhere, so that chemical change can quickly, if you've ever seen hypotonic solutions, hypotonic is that it can either cause stuff to expand rapidly or not expand rapidly, which they show here with a cell, as water or other things leave in and out, which can totally disrupt chemicals and cause bursting and stuff. And also your body can't adjust to rapid changes with chemical signals as well, and much more, because it's also, your body might see a rapid change with sodium and start pumping and overcompensating or undercompensating. All these things happen like that. So you have those things that could go around. Now, there is a lot of challenges with this design, but I think once you get a good design, it'll be highly modular. One of the challenges is making this whole thing is figuring out how to make everything of this thing not poisonous. Another thing is stop it from clotting, but we have, it still be dissolved in it, and we have a lot of ways. Fluorination can stop it clotting, a bunch of things. The problem with fluorination is a lot of fluorinating reactions are very hard, notoriously hard to do. It's what actually make Teflon, because fluorination reactions oftentimes have unwanted side products, and fluorine is very reactive, so how do you get it to react just right, chemically wise? But I'm sure we can do it. Less common fluorine is chlorine, which is less extreme than fluorine with all its properties, but still works. But how do you chlorinate it right? Well, I hope you found this interesting. Please like and subscribe. It really helps the channel out. Thank you very much. Goodbye.